Hi guys, Sinan on this side, and in this video we are going to see how to differentiate e to the power root x using the first principles. So our problem is d over dx e to the power root x, and if you know the chain rule, you know the answer to this is e to the power root x times the differentiation of root x, that is 1 over 2 root x. So this is what we need to get in the end using the first principles. So yeah, let's get started. So what does this actually give us in terms of the first principle? That is limit h tends to 0 e to the power root x plus h minus e to the power root x over h. And for some reason, let's just factor out e to the power root x. So what this gives us is this: limit h tends to 0 e to the power root x e to the power root x plus h minus root x minus 1 over h. Fine. And from, if you factor out this root x from this, you need to subtract that from the exponent. Anyways, if you see this is independent of h, so we can factor that out. So what we get is this: e to the power root x limit h tends to 0 e to the power root x plus h minus root x minus 1 over h. Right? Now let's say we multiply and divide by this number. So what we get is this is equal to e to the power root x limit h tends to 0 e to the power root x plus h minus root x minus 1 divided by root x plus h minus root of x times root of x plus h minus root of x divided by h. Fine. And since we know, we can separate the limits into two, so first limit will go on this and the second one on this. So what we get is this expression: e to the power root x limit h tends to 0 e to the power root x plus h minus root x minus 1 over root x plus h minus root of x times limit h tends to 0 root x plus h minus root x over h. Now let alpha is equal to root x plus h minus root of x. So if h tends to 0, this implies alpha goes to 0. Fine, because if h goes to 0, this term will get as close as possible to root x, and root x minus root x will be 0. So our question now becomes e to the power root x limit, not h but now alpha tends to 0 e to the power alpha minus 1 over alpha times limit h tends to 0 root x plus h minus root of x over h. Now if you have done your limit course properly, you know this limit goes to 1. Sorry, wrong pen. So this limit goes to 1. So now this becomes e to the power root x times 1 times limit h tends to 0 root x plus h minus root of x over h. And let's now just multiply and divide this expression with the conjugate of this, not exactly conjugate, but this times root x plus h plus root of x, and same number in the denominator, plus h plus root of x. Fine. Now if you multiply them using the formula a plus b, a minus b, you get a square minus b square, right? So what this gives us is e to the power root x as it is times limit h goes to 0, and so what we need to do is this square minus this square. So what this gives us is x plus h minus x over this expression, that is root x plus h plus root of x. Now if you see, this x cancels this, so what we are left with is e to the power root of x limit h tends to 0, and yeah, we forgot this h, right? So this becomes h over h times root of x plus h plus root of x. And I think now you will be able to see the answer. We get e to the power root x, this h cancels this, get limit h goes to 0, 1 over root of x plus h plus root of x. And since you know this is not an indeterminate form, so what we can write this as, we can just actually place the value of h in this expression. This gives us e to the power root of x, 1 over root of x plus 0 plus root of x, which is our final answer, e to the power root of x over 2 times root of x. So finally what we can say is the derivative of e to the power root x is e to the power root x over 2 times root x, using both chain rule and the first principle. So yeah, that's the video.